let's get this show on the road then. I'll start with questions. Does anybody have anything from the sections 1, 2? Morgan?
Can we do like 5 and 6?
Sure. So you said 5 and 6? Sure. So first thing I'm going to do is I'm going to just draw the picture so I can determine whether this is a what situation we're in. Okay, so I am in a SSA situation. I can tell because the given angle is not in between the two given sides. I notice that my given angle here is not acute. So what I need to check then for is that the longest side is opposite the biggest angle. Uh-oh, it's not, right? Oops. Let's see. So that tells me 0 triangles are possible because the hypotenuse is in the wrong spot, right? 6 then. Again, I just draw my triangles identical because I don't care about scale. It just, all I'm using it for is to figure out what the situation is. So again, this is an SSA situation. Here that my given angle is acute. So the thing I want to check is that if the side opposite is the shorter of the two sides. So this is the 0, 1, or 2 triangle situation. So to check which one it is, I'm going to set up a law of sines. So do sine B over B. Put the number in. Equals sine A over A. And if I cross multiply and divide, I'm going to get a value for sine A. And that number is going to tell me what's going on. So I'm going to go into my calculator and type in 13 sine 87 divided by 4. If I haven't been on my calculator in a while, I'm going to make sure I check my mode. I know mine's in degree mode though, because I haven't done anything other than degree mode stuff with it. Since I've come back from break, I've been using it a lot. The number I get there is greater than 1. That tells me 0 triangles. If it was equal to 1, it would be 1 triangle. If it was less than 1, it would be 2 triangles. Is that?
Yeah.
Okay. So they're both 0 triangles, but for different reasons. Feel good?
Yeah.
Or better anyways? We'll settle for better. Others, anybody else? Okie madokis. Let's then start the new stuff for today. So last time we talked about how to deal with solving triangles that are ASA, AAS, and SSA cases, that we can just use the law of sines to handle these. That leaves us with 2 other cases where we can still solve the triangle. Side angle side and side side side. Those are going to be law of cosines situations. So let's see what that law of cosines is, right? So let me just drop this image in here. So here's our law of cosines formulas. Notice this is just 3 different versions of the same formula, right? So if you look at this, it's like side A squared is equal to side B squared plus side C squared minus 2 times side B times side C times cosine of angle A. If I look at this formula, what does it look like a little bit or remind us of? Pythagorean theorem, right? Except we have this extra correction factor tacked on to the end, right? That extra correction factor is to account for this not necessarily being a right triangle. In the case where angle A is a right angle and we're in a right triangle, do you guys remember what cosine of 90 degrees is? 0. So that correction factor just drops off and you're left with the Pythagorean theorem in a case that you're dealing with a right triangle, which is lovely, right? We'd love for when one formula is just kind of a generalization of another, right? This is just the more general version of the Pythagorean theorem. Everybody feel okay here? So if I look at, say, this first example, I can use it to solve for side A. In doing that, I'm going to need side B. I'm going to need side C, have B and C, and then angle A. So what situation is this coming under? Yeah, this is like our side angle side situation. Everybody's cool with that? So it'll allow us to find the third side in a side angle side situation. Okay. Well, that's one of the 2 cases. What about the side situation? Well, we're going to develop a different formula to handle that. Oh, no, I'm dumb. We're not developing poop. I'm just, never mind. I'm going crazy. I just forgot where I was at. I looked at the mass day lunch schedule and I was like, oh, I got lots of time. I'm just coming back. I'm gonna be like 10 minutes early. And I was walking through the halls. I'm like, I'm not 10 minutes early. I did something very wrong. So I'm just a little flustered now. Ever happened to you?
Yeah.
Yeah, no bells really. Yeah. Anyways, they got me. All right, so let's just do a quick example. So again, I'm just going to start by drawing my picture. Should be pretty clear here that this is a side angle side situation because I noticed that the given angle is in between the 2 given sides. Easy to see that. So what are we going to solve for? Angle B, C, or A, side A? Which one are we doing first? Side A. In a side angle side situation, it's easy to tell because whatever the given angle is, that's the given side we'll solve for first. So I'll just plug this into the law of cosines. Nothing can go wrong. I don't have to think too hard about it. So just drop that all into the law of cosines. So that's going to give me my value for a squared. What do I need to do to get a?
Square both sides.
Yep, square root both sides. Now remember, when we square root both sides of an equation, it creates a plus or minus. Why am I not worrying about the plus or minus in this case?
So this is a measurement, so that's plus.
Yeah, it's the side length of a triangle. That's a measurement. It has to be a positive number. So I'm just going to be thorough and mention that we do generate a plus or minus here, but like, who cares? We're never going to need one for a situation like this where we're using the law of cosines to figure out a length of something. And now it's just calculator time. Now, as tempting as it might be, my suggestion to you is to never try to like simplify this more. Just type this into your calculator all in one swoop. The most common mistakes I see students make are just like violating the order of operations and doing something silly and simplifying wrong, when you could just type it all in your calculator as it's written and just like avoid any of that problems. Let the calculator handle all the order of operations stuff for you. The calculator won't mess that up unless you do something dumb to tell it to do it in the wrong order. So we get that. We get 951. Everybody cool with that? So the next step is we need to find angle B and angle C. Which one should we do first? Not whichever one I want. Now it matters. Why does it matter all of a sudden?
You have to do small. I don't know.
Okay. You were right that we want to do the smaller one first, but why does it matter which one we do?
Oh, because if you can only use the law for acute angles, and it could be obtuse.
Well, not so much that, but what we have to be careful about is we're now going to be doing an SSA problem where we have two sides in an angle and we're finding the other angle. So what we need to make sure we're doing is avoiding the ambiguous case. That's what we want to make sure that we're avoiding, so we don't have to deal with like two sets of measurements and figuring out which set of measurements is actually the answer we want. Right? That's rough. To ensure that we never have to do that, we want to find the smaller angle next. How can I tell which one is smaller, angle B or angle C?
Side length.
Yeah, I can use the side length. Which side length is smaller? B. So which angle am I going to be finding? B. So I'm just going to set up a law of sines to do this part. So do sine A over A equals sine B over B. So I'll cross multiply, divide, and then do the sine inverse. I'm just going to do that all kind of in one shot here without showing the algebra. Is that okay for you guys? Spent like a whole day yesterday doing this algebra, so I feel like it's okay to just kind of shortcut through it and just write down what I'm going to type into my calculator. So sine inverse, alpha y equals 14 sine 34. And then I'll just use the answer command because I'll take all those decimals so I can get a really accurate answer. So I get 5544. And then lastly, then we'll find angle C. Since we have angle A and we have angle B, finding angle C next is going to be a piece of cake. Uh-oh. Somebody's popular. So again, the key here to remember is when we're going to find the angles in this side angle side situation, you want to find the smallest angle first. Okay? Well, you got to get the B by itself, right? So we have to cancel off the sine in front. What cancels a sine? A sine inverse. Yeah, no problem. Fire away the questions as they come up. We'll do another example. So this is the pretty easy to see just from looking at the problem. Which situation is this? side, 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 I can tell because none of those things have a degree symbol next to them, so it must be 3 sides. Now, question. I've given you 3 side lengths. How do I know those actually can make a triangle? Any 3 numbers, will those correspond to side lengths of a triangle?
Is it like,
If you add 2 of them, it might be bigger than 1. Yeah.
Okay, so excellent. So yeah, not every 3 side lengths are going to correspond to 3 side lengths in a triangle. Like if I do 1, 1, and 10,000, obviously you can't make a triangle out of those, right? The 10,000 is way too long. So the thing you have to check is that the sum of the 2 legs has to be greater than the hypotenuse, which is pretty much exactly what Joe said, but I know it's definitely what he meant. He didn't say leg, leg, and hypotenuse, but you definitely have to make sure that the longest one is smaller than the sum of the 2 others. What if you have 2 that are tied for biggest? It's fine. You know, let either one of the 2 biggest you could call the hypotenuse. The sum of the other 2 just has to be bigger than that, which, assuming that the side length is non-zero, is trivially going to happen. So here, 5 plus 8 is greater than 10. You betcha. Do I even care what 5 plus 8 is? Nah, I just care that it's bigger than 10. Everybody's cool with that? Okay. So, which angle should I solve for first? I have enough information to solve for either angle P, Q, or R. Which one should I solve for first, and does it matter? No. R. I want to find the biggest one first. Yeah. The reason I go for the biggest angle first is because if that angle is is obtuse, or actually just greater than or equal to 90 degrees, then I can't fall into an ambiguous case, and it doesn't really matter the order in which I do solve for the other 2 angles, because the SSA has an obtuse angle in it, so I'm good. Are all triangles have an obtuse angle in it, though? No. So I'm still going to do the second 2 angles in the same order, whether I get a non-acute angle here on the first angle or not. But that's why I'm doing it in this order. So in our case, that biggest angle is going to be which one? A lot of pirates in the room. Arr! No, not funny. You guys are a bunch of jerks, leaving me out to hang. I'm just joking. You're not jerks. Okay, so I'm going to just write this formula with letters in it instead of numbers, because what we're going to do here is we're going to solve for cap R algebraically and just kind of use that as to create a formula, an alternate version for the law of cosine, so I don't have to do this algebra every single time. I'll just have another version of the formula where the angle's already separated. Sound good to you guys? Okay. So if I'm solving for angle R, what should I do first to get that angle R by itself? I would not square root both sides. Yeah, so you want to run the reverse order of operations. So the last thing you do in order of operations is add and subtract. I want to undo any addition or subtraction happening to my variable, which is the cap R. So P and Q are being added. So we'll subtract those guys over first. Then what? Divide by negative 2PQ. Excellent. And then to get rid of the cosine R, we do? Yeah, cosine inverse. Great. Now I'm just going to take this result and I'm going to go back to my law of cosines formula and just write an alternate version of each of the law of cosine formulas where the angle is already separated. Everybody's cool with that? So rather than having to do that algebra every time we want to solve for an angle, I'm just going to write a version here where that's already been done for me. Okay. Now let's go back to that example and actually plug some stuff in and grind through that to our answer. So we get that r is equal to cosine inverse of 10 squared minus 5 squared minus 8 squared over negative 2 times 5 times 8. So go to my calculator. And here, if you haven't been using that fraction command, I would strongly encourage you to do so because you need a whole heap of parentheses to make sure this happens in the right way. It's very easy to goof it up. To get that fraction bar, you press alpha, y equals, and press the first option. And now I can just type this in exactly like it looks on my sheet of paper. And that makes life just a little bit easier. So we get 97.90. Yes.
Can you use the alpha and the x variable for the fraction as well?
I don't know. I haven't tried that shortcut before. Alpha x. Yeah, it doesn't look like it works on this one. But I mean, again, whatever you're doing to get the fraction bar, it's fine. I just like using it because now I don't need the parentheses. I can just write it like it looks. If that's the shortcut that works on yours, go for it. You know what I mean? And if you're ever like, I wonder how I do that on my calculator. How do you figure out how to do something on your calculator? Go to YouTube, write in the name of your calculator, and then like, how do I whatever? And somebody on YouTube will show you like the buttons to push to do it. Or you could ask me, I probably know. Or can probably figure it out, but that's how I figure things out if I'm not sure. Like every once in a while somebody has like a Casio calculator. I'm like, oh goodness, I don't know how to use this thing at all. And that's what I end up having to do, is go to YouTube. All right. So now we have two more angles to solve for, angle P and angle Q. Which one should I do first? I want to do the smaller angle first. In this case, that would be angle P. So I'll do sine of R over R equals sine of P over P. I know P is the smallest one because it's opposite the smallest side. Again, now technically speaking, in this problem, since R is obtuse, it doesn't really matter which one I do. But if I do a different order sometimes and then a different order another time, I'm going to screw that up when it matters. So I'm always just going to do the same order because it's fine if it doesn't matter, and it definitely matters when it does matter. I'm just going to do the same order no matter what. You guys okay with that? Anyway, so we go ahead, we cross multiply, divide, and do the sine inverse, and we get angle P is the sine inverse of 5 times sine 97.90 divided by 10. Let's fire up the old calculator for that. Sine inverse alpha y equals 5 sine, and I'm going to do the ants command, so I'll take all those decimal points with me because I'm a maniac and want to get the most accurate answer possible. And I get 2969. And then to get angle Q, I've got 2 of the 3, so it's real easy to just use the triangle sum theorem from algebra class. Or, I'm sorry, not algebra, geometry. Woo! And just do that to get the third. So I get 5241 for my last one. So again, with the law of cosines, when I'm using those, if I have to do a side situation, I want to find the biggest angle and then the smallest angle. If I'm in a side angle side scenario, I want to find the smallest angle. Everybody's cool with that? Again, easier, I think, in general than the law of sines problems, specifically because there's no crazy SSA case where like a million different things can happen. All right, so one more thing to talk about. And that's about areas of triangles. So let's go back to geometry. What's the area formula for a triangle? Yep, 1/2 base times height or base times height divided by 2. Either one is the same thing. In the triangle I've just drawn there, where would the base be? Sure, we can make it this bottom side. And what would the height be then? Yeah, it's the altitude, right? It's the perpendicular line that passes through that opposite vertex and is perpendicular to the base. What's the problem with that measurement for our height? It's not a side length, right? That's given to me. If that value isn't given to me, that's kind of a hassle to come up with, right? So what we're going to do here is we're going to develop some formulas that don't depend on the height. So I'm going to create an area formula for my triangle that doesn't depend on height. Only the side lengths or angle measures. Okay? So what I think about here is like, okay, well, I guess let's give this stuff a name. Call that A, B, C. I chose to put B at the top this time so that I already labeled the one side as little b for base. So the little b can still be the name for it. Felt less confusing to do it that way. I noticed, though, that in yellow there, what I've highlighted makes a right triangle, correct? So I can say something like sine of A is equal to h over c. And I'm thrilled about that because I have an h in that formula. So if I multiply both sides by c to get the h by itself, I can say h equals c times a. So if I substitute that value into my original, I get 1/2 BC times sine of angle A. And if I look at what I have here, I need B, I need C, and I need A. When is it going to be most useful? Or when is this formula going to be most useful? In a side angle side situation. Absolutely. Now come now. What just happened here? And as you might have guessed, I can write that in 3 different ways. It doesn't have to be stuck with using angle B and sides BC. Would not be hard to imagine how I would manipulate this formula to get 3 different or 2 other versions of it, right? Basically, all I do is relabel my triangle and I can get the other version. Now, okay, so that works. Obviously, it works for side angle side situations. What if I have an angle side angle or an angle angle side or even an SSA situation? I'm still going to use this same formula, but I'm going to have to do something first. Yeah, I'm going to just use the law of sines to find one more side. So I can create a side angle side situation and then just use my formula. So that's the worst case scenario, is like, oh no, I have to do a law of sines to solve another side. Ooh. The worst one is if it's the side angle side situation, because you have to, the third side, you have to do the other 2 pieces first to get it. Ugh. Okay, what scenario haven't we talked about? Side, side, side. What about that one? So you could use the law of cosines to find an angle, or we can create a formula that uses only the 3 side lengths, so we don't have to do any pre-solving. Let's develop that. Sound good? All right, so what we're about to do is a process I would never expect you to repeat. I'm just going to show you how we would go about building this formula from our existing area formula, but this one is going to involve only the side lengths A, B, and C in it. John Paul, what's up? Certainly. So this is a little bit of a lengthy process, developing this formula. And again, not something I'd ever ask you to repeat. Although completely within our capabilities, mathematics, I'm not going to use anything that's like unbelievably sneaky. It's just like seeing what to do and like putting it all together is a lot to ask for somebody that's never done it before. All right, so this is what we're starting with, our area formula. And what I want to end up with is an area formula that has no angle measures in it and only the side lengths A, B, and C. Okay? So I'm just going to start by multiplying both sides by 4. And then I'm going to square both sides. So that gives me 16a squared or 16 area squared equals 4 squared times a squared times b squared times sine squared c. Now, if I remember, sine squared is the same as 1 minus cosine squared. Oh, I didn't mean 4 squared, dum-dum. I just meant 4. Right? Sine squared is 1 minus cosine squared. I'm going to then distribute that 4a squared b squared through. And if I notice here, the first piece, that 4a squared b squared, looks like something squared. And over here, that 4a squared b squared cosine squared looks like something squared. Everybody's okay with that? Ooh. Look at that. Do you recognize that from any place? Yeah, that was like the correction factor on the law of cosines, right? If we go back and we look. See? So what I'm going to do is I'm going to use the law of cosines to make a substitution. So if I add the 2ab cosine c to the other side, and then subtract the c squared from the other side, I can make a substitution now. Like that. Which I feel great about, because what have I done here? I eliminated the angle measure, right? So now everything is just side lengths. I'm going to do some work now to pretty this up, though, because right now it's set equal to 16a squared, area squared, and I don't love that part. I notice here that I have something squared minus something squared, right? I can factor that as a difference of 2 squares. Everybody okay there? I'm going to distribute my negative through this one and then just do a little bit of rearranging in there. So I'll have c squared, and I'll have minus a squared minus 2ab plus b squared. And then I'll do a similar, just a little bit of rearranging in here. And I'll just put a parenthesis here for emphasis. Recognize those polynomials. Those are the perfect square factoring pattern. So I can factor each one of those. That's going to be a minus b quantity squared. And the other one will be a plus b quantity squared. Look what we have in each set of parentheses there. It's another difference of two squares. Ah, so much factoring, Mr. Kulik. Yeah, but it'll be worth it. Okay. And I'm just going to do some distributing through and rearranging. Let's do that, actually. Now I'm going to make a substitution. So I'm going to define a new variable s that's equal to a plus b plus c divided by 2. For those of you that care, we refer to this quantity as a semi-perimeter. Semi because it's divided by 2, and perimeter because a plus b plus c is the perimeter of a triangle. So if I go ahead and I make some common denominators and do a little bit of rearranging, this first piece becomes 2c minus 2a. Or I'm sorry, 2s minus 2a. Then I have 2s minus 2b. And I have 2s minus 2c. And then I just have 2s. You can take my word for that. If you wanted to grind through the details, you'll see that you do get the exact same things, but it's just like a pain in the tuchus to show it. I'm just going to ask for a little bit of grace on that one. Take my word for it. Notice in each of these sets of parentheses, there's a factor of 2. And since this is multiplication, I can multiply these things in any order I want. Specifically, I'm going to multiply all those 2's together. 2 times 2 times 2 times 2 is 16. And then I'll just write it in this order. If I divide both sides by 16, I get rid of the 16s, and if I square root both sides, I get this as my final result for my area, where S is, again, a plus b plus c over 2. This formula has a name. It's called Heron's formula. I believe Heron was an Egyptian mathematician, but he might have actually really been a Greek mathematician because this was post Alexander the Great in Egypt. So everybody in the Middle East was really Greek at that point for a little while, or at least like culturally Greek. So there's our Heron's formula. Again, will you ever have to repeat that process? Goodness, no. But is it important we see kind of how we build out a formula from something? In an honors course, I think that's a reasonable expectation that we can kind of follow along. Notice that nothing I did here was really like beyond our capabilities mathematics-wise. other than it was like a lot of stuff to keep track of, a lot of steps, and a lot of clever use of like factoring things in ways that like, oh yeah, I guess I see that's a difference of two squares. I wouldn't have noticed it without you pointing it out to me. You know, or, oh yeah, I see that was part of the law of cosines, but I might not have noticed if you didn't point it out to me. But we didn't really do anything tremendously complicated there. Let's go and do a couple of examples, and then we're done for today. Sound good to you guys? Yeah. All right. So here we're asked to find the area for the triangle, and we're given some measurements. So I notice that this is either a side angle side or a side angle because I'm given one angle and two sides. To figure it out, which one I have, it's probably easiest just to draw the picture. Feel like I'm less likely to make a mistake that way. What situation did we end up with? Side angle side. Oh, well, that's the first area formula. That's really easy. So 1/2 b times c times sine A. I can apply it directly. I don't have to do any other gobbledygooks. It just comes and goes and plugs straight into my calculator. I love it. Super easy. It takes me like literally 30 seconds to do the problem. I'm super excited. So I get 9207. Yes, sir.
I got kind of lost. But what do we do with that?
It's an area formula.
So when it's
So if it's side, you can solve that area directly.
three sides to the
Yep. Yep. So S you calculate with A, B, and C, the three sides, and then A, B, and C are just the three sides. So it's all the inputs are just the three sides. So 9207 is an answer, but it's incomplete. What do I still need to have with this answer? A unit. What unit should be attached to this?
millimeters squared.
Millimeters squared. Mr. Kulik, will you be picky about that on the test or whatever? If I gave you a unit attached to the problem, I better have a unit on my answer. If it's an area, it needs to be a square unit. If it's a length, it needs to be a linear unit.
Volume.
Not in this chapter. We do a volume chapter later, or a volume and surface area chapter later, but not in this chapter. Okay. So Joe, as to your question, let's do another example. What situation is this? Side. So if I'm going to do this, I should be able to use that new formula we just generated. Before I do that, though, what do I need to do? I have to check to make sure this triangle is possible. So again, leg plus leg has to be greater than the hypotenuse. 5 plus 8 is greater than 10. So I am okay there. So I'm going to start by calculating my value for S. So 5 plus 8 plus 10 is 23. 23 over 2 is 11.5. So my area is going to be the square root of S times S minus A. What's 11.5 minus 5? 6.5. And then S minus B. What's 11.5 minus 8? 3.5. And then I have S minus C. 11.5 minus 10 is 1.5. Do I really need to do those arithmetics? No, but like, boy, that creates a lot less typing for me when I type this into my calculator. And it's like easy integer addition, subtraction. So I usually go ahead and do that here because I'm pretty confident in my addition subtraction skills. If you're not, type in the whole thing. No problem in doing that. So I get 1981 watts. Yeah. So that's the point of Heron's formula. It allows you to solve an area problem like this directly without having to muck around finding an angle, which you could do if you wanted. You could do law of cosines, find an angle, and then use the first formula. But this is faster, I think. All right. Guess what? That's it for Chapter 7. So on to Sunday's homework. We'll add on 15 to 30. Thursday, what haven't we done yet this chapter? A homework quiz. What should you expect to happen on Thursday? Homework quiz. What else are we going to do Thursday? We're going to have the review day. And what's going to happen? What would it be, like Wednesday? No, Tuesday next week? Tuesday next week would be the test. We don't have school on Monday, Martin Luther King Day. Okay. What would you expect to do on the homework quiz? Solve triangles using law of sines and cosines. You don't need to memorize the formulas. I'll give them to you. Or at least the basic version of them. Right? Everybody's cool?
There's no area.
No area. I don't think so. I don't remember anymore, but I don't think so. I printed them out earlier and ordered the copies, but I don't have the printout anymore to look at.
Yeah, you're good.
I was pretty sure it was just solving triangles.
Okay, so we need to like know how these triangles like solve.
If you run into like an SSA case and I ask you to solve it, I would expect that you're able to give me like no solution if it's 0 or 2 sets of answers if there's 2 sets of answers.